Let's look at the do while loop next. This is an alternative of the while loop statement. The only difference being you have do first. This entire do does not have any conditional check, which means you can proceed without having this conditional at the very first pass of the iterations. This entire iteration consists of one extra than the while loop, allowing the users to run the entire statement, this entire block once more than the other alternative. And you have this conditional check. And notice that there is a semicolon at the end. It's pretty much the same condition as you have from the other statement you saw earlier. This is a very complicated series of conditionals with the logical statements right in between. But you can evaluate this. The entire condition evaluates to either true or false, period. If true, then this entire statement block will be evaluated again. So that's the essence of a do while statement. Nothing else is different from all the other statements. I do want to go over this one other control statement called for loop. Let's look at it. Inside this for loop statement, the signature goes like this. There's actually 3 blocks in a for conditional, and that is very different than the other conditional you saw earlier. Initialization happens only once. On initialization of whatever this variable is, counter, we said. If counter is I, then this I could be evaluated to, I don't know, maybe 5. And then your loop conditional plus the increment gets tested every single time the loop is complete. If conditional evaluates to true, this is true or false, then your increment happens. This increment can also be decrement. So it could be I++ or I minus minus. Doesn't matter. Sometimes in C++, you can also have prefix version of writing this, like minus minus I plus plus I. We'll talk about the differences in other lectures, but right now just focus on this entire signature. Your for loop signature could be converted to while and vice versa. While does not have this initialization. And notice these 3 blocks I mentioned in a for loop, they're all separated by semicolon. And this is semicolon. Sometimes a student will make a mistake and put colon instead, meaning 2 period, 2 dots. That's not correct. It has to be semicolon. Otherwise, you will run into syntax issues. Your compiler will not let you pass. This whole initialization for the while loop sits outside of your while loop because while loop has only a conditional check in the middle. It doesn't have a space or spot for initialization. So a lot of times, let's say if you want to initialize your index or counter, you got to do it outside of the while loop, like I. And this initialization should be done outside of that loop. However, in here, you can simply write integer I equals 0. Sometimes people take this entire int declaration outside of this initialization. That is fine, assuming that this I will be used elsewhere. But to not confuse the use of your counter, because your counter here is obviously for this entire for loop. We typically don't take this integer declaration outside of this initialization loop. Making it outside of this for loop is not necessary because it introduces some confusions later on. This is just some of the best practices that I encountered. So this wraps up the for statement. Let's look at a nested for loop and see how that works. Here's a quick illustration of a nested for loop. This is a very expensive, meaning computationally intensive for loop because you're looping through not only the outer, but the inner as well. This looks like a selection sort or something that commands O of n squared complexity. I'll talk about this in other classes. This big O simply measures the time and space complexity of this solution. As you can see, there's a loop that drives the inner. So you can consider this inner block as literally a block of code that will be driven from I equals 1 to 10 inclusive. So there's 10 loops on the outer loop. And the inner loop itself is from 1 to j less than I. So it looks like this will be iterated 10 times and there will be another iterations inside of it. Meanwhile, your I will be incremented, so is j. In the first outer loop, I is 1, so is j. So when your flow control enters this for I equals 1 loop, or the very first loop, j is also 1, and j is less than or equal to 1, this will be evaluated. And then j is going to be incremented to 2. So j is 2, and that ends the inner loop. And your inner loop goes to outside, which means your I is going to be checked against whether this is less than or equal to 10. Of course, I is less than 10 because it's 1. Then I is going to be incremented to 2. So you have this racing condition where the value of I is incremented after j, but j is always less than or equal to I because of that equal. So technically, this entire inner loop should be run 10 times until I reaches 10. And j will still be less than or equal to I, which is 10, until the other loop stops. You should be able to figure out how many times the inner loop is executed based on my description. This concludes this portion of the C programming review.